Hello and welcome to this video on inequalities involving division by x. And we've been set this problem. Consider the inequality 10 divided by x is greater than 5. When is the inequality true? So you might start thinking, well, I know that it's true when x is less than 2. For example, when x is 1, we get 10 is greater than 5, which is true. It's not true when x is greater than 2. So if x was, say, 10 itself, we get 1, which is not greater than 5. It's not true when x is 0, because we can't divide by 0, so 10 over x will be undefined. And it's also not true when x is negative. So whatever value of x you have which is negative, the left-hand side will be negative, and it will not be greater than 5. So solving this inequality is not as straightforward as just timesing both sides by x, getting 10 is greater than 5x divided by 5, and saying that x is less than 2, because not all values less than 2 are solutions to the inequality. And we can see that from the graph. Okay, the 10 over x is given by the red line, 5 is given by the blue line, and if we want 10 over x to be greater than 5, we want the red line to be higher up the y-axis than the blue line. And that is only true between 0 and where the lines meet. And the reason we can't just multiply both sides by x is because we don't know whether x is positive or negative. It could be either. We have to assume it could be either. And you can't multiply both sides of an inequality by a negative without swapping the direction of the inequality. So what we do instead is to multiply by something that we know to be positive, so that we don't have to swap the inequality around. And in this case, we could times both sides by x squared, because x squared is going to be positive. So on the left we have 10x, on the right we have 5x squared. We can rearrange it and solve the quadratic, and we get that x minus 2 is less than 0, and that is in between, so we know that x is between 0 and 2, because 0 and 2 are our critical values, and that does indeed correspond with the graph. This example is very similar. Find the set of values for which 5 over x minus 2 is less than 3, but we can't just times both sides by x squared. That wouldn't make sense. Okay, before we look at how to solve it, let's look at the graphs. So the red graph is your 5 over x minus 2, the blue line is 3, and we can see that when 5 over x minus 2 is less than 3, when the red is below the blue, that is two separate regions on our graph. If we were to solve the inequality as if it was equals, so 5 over x minus 2 equaled 3, we'd get 11/3 as the answer. So it turns out that there are two regions, one on the left, which goes all the way up to x is 2, and on the right-hand side, when x is greater than 11/3, and in set notation, we need a union symbol. So to solve this, we need to times by something which is positive, and which is going to get rid of the x minus 2 from the denominator. So we can times it by x minus 2 squared. And if we do that to both sides, we end up with 3x minus 11, x minus 2 is greater than 0. So it's an either side, as we discovered on the previous slide. X is less than 2, x is greater than 11/3, and there is our solution in set notation. To finish off, here are 5 for you to try. Answers will be available separately. Thank you for listening.